So nitrogen's central. Nitrogen has 5 valence electrons. Hydrogen has 1. There's 4 of them. There's 9. But because we have a positive charge, we take 1 away. So that means we have 8 valence electrons to deal with. Okay. Hydrogen wants 2. Do the hydrogens have 2? They do, right? Because they each have a bond. Okay. Nitrogen wants 8. Does nitrogen have 8? Because there's 4 bonds. Just check the valence electrons. There's 2 here, 2 there, 2 there, 2 there. So we have 8 valence electrons. So we've accounted for everything. But if it's an ion, like this, positive charge, what you have to do is put brackets around it and put a plus sign there to represent it's an ion. Because normally nitrogen only wants to form 3 bonds and have an electron pair. In this case, we get an ammonium ion, so we have to represent the charge. Okay? All right. HF. Yep. So you just, if you look here, you're basically just counting as you go across the periodic table. Hydrogen has 1 valence electron. Helium has 2. Lithium has 1. Beryllium has 2. 3, 4, 5, 6, 7, 8. You just count. Okay? All right. HF. How many valence electrons does fluorine have? 7. And hydrogen has 1. So we have 8 valence electrons. There's only 1 bond that can form. HF. That gives me 2 valence electrons, right? Sorry? Is it ionic? Well, let's check the electronegativity. H is 2.1. Where's fluorine? 4. 1.9. I guess if we're using 1.7, we have to say it's ionic, don't we? Yeah. That's actually what I was going to point out in the quiz. Is a couple people got the exceptions. So it's actually covalent, but it's because hydrogen's really small and fluorine's really strong. So it's one of the exceptions. So HF delta En is like 1.9, but it's one of the exceptions. It's actually covalent. Where do the other... I forgot what I was saying. Oh, there's 2 valence electrons in that bond. So there's 6 left, right? 6 valence electrons left that have to be distributed around fluorine. All right. N2. How many valence electrons are in nitrogen? 5. And we have 2. So we have 10 valence electrons. How many bonds does nitrogen want to form? 3. So you have 2 nitrogen molecules. Each one wants to form 3 bonds. 1, 2, 3. How many valence electrons are in those 3 bonds? There's 6, right? So how many are left? So minus the 6 VE gives me 4 left. You have to distribute them between the 2 molecules. Each one, or between the 2 atoms, each one wants 8 total. They each have 6. So we just put lone pairs on each one. Yep. Sorry. Right now, no. But in general, the electrons, because these are electrons too, right? They want to be far apart, so it's the most stable. We're gonna look at the structure, maybe today, but tomorrow for sure. Okay. Right now, if you put them on top, yeah, I would give you that for now. Okay, but just know that they would be on the side. Okay. All right, CO2. Which atom is in the middle? It's going to be carbon, because carbon wants to form 4 bonds. Oxygen wants to form 2 bonds. So the one that forms the most will be in the center. CO. We got to do valence electrons. Carbon has how many valence electrons? 4. Oxygen has 6, but there's 2. So that's 12. We have 16 valence electrons we have to account for. Okay. Carbon wants 4 bonds. Oxygen wants 2. Okay. How many valence electrons are in those 4 bonds? 8. There's 8 in those 2 bonds. So that means there's 8 left over, right? I have to distribute those. Do I need to put them on the carbon? No, because carbon's got its 8, right? Through the 4 bonds. But oxygen only has 2, 4. It needs 4 more here, and as does this one. So if I'm going to distribute them, technically you can put them top and bottom, but it'd actually be something like that on the side. I don't care if you put them top and bottom, though. If you wrote them like this, that's fine. H2O. You want to take a crack at H2O? I think I've even shown you H2O before. Are you ready? Did you get that? So we have 8 valence electrons. Oxygen wants to form 2 bonds, and hydrogen only wants 1. So there's your 2 bonds. But there's still 4 more valence electrons because hydrogen needs 8 total. Can you do H3O? Try H3O plus. that what we got? If you have it pointing up, that's fine too. Some version of that. And just remember, if you're doing a charged ion, you gotta put brackets with the charge on it. Are we good? All right. COCl2. So now there's 3 different types of atoms here. How many bonds does carbon want to form? 4. How many does oxygen want to form? 2. How many does chlorine want to form? 1. So what is the central atom? It's carbon because it wants to form the most bonds. So carbon goes in the center. You got an oxygen, you got 2 chlorines. Or you could write the oxygen below, or it doesn't matter the orientation really. I'm not too worried about that. Okay. Chlorine only wants to form 1 bond. So we're going to draw a bond in. Bond, bond. Okay. Oxygen wants to form 2, and carbon needs 4. So what's the bond between oxygen and carbon? It's a double bond. Okay. Now we got to figure out the valence electrons. So carbon has 4 valence electrons, oxygen has 6, and chlorine has 7 times 2. That gives us 24 valence electrons. How many do we have in the bonds that we have there? We got 8, right? Because there's 4 bonds. 2, 4, 6, 8. So if you take away 8, you're left with 16 left. How many do I have to put on oxygen? 4, right? Because it already has 2 bonds, which means it's got 2 4 electrons. It wants 8, so I just put 4 on oxygen. There's 4. Now I got 12 left, so I distribute those between the chlorines. Then you're done. NO2 minus. How many valence electrons does nitrogen have? 5. How many does oxygen have? 6, but there's 2 of them. And if it's a negative charge, you have to add an extra electron. So that's going to be 6. That's going to be 18. What's the central atom here? Nitrogen, because it wants 3 bonds, and oxygen only wants 2. So NO. All right. How are we going to do this? So, what should we do? Okay, so we have 18 valence electrons. Nitrogen wants to form 3 bonds. And oxygen wants 2. But we've got 2 different oxygen molecules, right? So if we put a double bond there, okay, say we did that. Say you did that. Maybe you don't write unless you're doing it in pencil. Okay. What if you did this? Okay. How many electrons have we accounted for so far? There's 8 there, right? So that would leave us 10 left over. How do I distribute those 10? Well, oxygen is going to want, it's like There's 8, right? Yes? So I still have 2 more to give, right? Where are they going to go? So you want me to put 2 more electrons on nitrogen? Like that? How many electrons does nitrogen have now? It's got 10. Does it want 10? Nitrogen wants 10. It wants 8, right? So this cannot be the structure. Okay? So what if we try? So clearly there can't be 2 double bonds. So let's try 2 doubles and a single. Now let's do it. How many? There's 6 electrons there, right? So that leaves me with 12 left. Oxygen wants 8. So I can put 2 there, or 4 there, sorry. How many would I have to put on the other oxygen to give it 8? You'd have to put 6, right? Okay. That gives me, that's 10. I still have 2 left over. Where can those 2 go? And where should they go? How many does nitrogen have right now? It's got 6. And I have 2 electrons left over. So if you put them on nitrogen, well, you'd probably write them like that. Yeah. It'd be the most stable. No, because this would give you 8 and it'd be all paired, right? Yeah. So now that works. Nitrogen's happy and oxygen's happy. The other one didn't work out. We had 2 extra floating electrons. So this has a negative charge, so you have to do that. This is, look, I'm not going to ask you this, but it doesn't stay like this because this double bond can clearly flip to the other one. So you don't draw this. If you can, well, you can if you want. But you would get this as well. It would flip back and forth. It's called a resonance structure. All right. But we're not going to talk about that. Okay. But the bond isn't just sitting there static. It's actually going back and forth. Essentially, yeah. But yeah, there's a resonance structure. This is like 2nd, 3rd year chemistry. We don't care about that stuff. All right. All right. I care that if you did that. Or if you drew the bottom one, have the double bond on the other side, that's fine as well. It's stable. Well, it's an ion, so it's not completely stable. It'll grab any proton that's floating around, right? We haven't talked about that yet. We'll talk about that. Okay. HOCl. HOCl. Which one's the central? Oxygen, because it wants to form 2 bonds, and chlorine and hydrogen only want to form 1. So oxygen sits in the middle. We'll put chlorine here, hydrogen there. It doesn't matter if you've had them flip-flopped. How many valence electrons are there? Sorry? They wouldn't be at right. Might be, yeah. I don't really care. We're going to look at the structures in a bit. I'm trying to think of what it would be. Sorry, how many valence electrons? There's 1 for the hydrogen, 6 for the oxygen, 7, 14. Yep. Oxygen wants to form 2 bonds, right? Chlorine and hydrogen only want to form 1, so that makes it easy. We'll just go, okay. That gives me 4 electrons used up. So I've got 10 left over that I have to deal with. Those 10 have to be distributed between oxygen and chlorine because hydrogen only ever wants 2. So I'll put 4 of them on oxygen and 6 of them on chlorine. All right. This next one, this is methanol. This is paint thinner. Okay. The unit after Christmas is organics, and that's what this is. when you're dealing with organics, if you see an OH group like that, written that way, the oxygen and the hydrogen are bonded together. Okay? So this is going to be carbons at the center, hydrogen, 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 and the OH looks like that. OH is like a group to itself. It's an alcohol group. Okay, how many valence electrons are in this guy? So carbon's got 4, plus there's 4 hydrogens times 1, plus the 6, 8, 16, 14, is that what you said? 14 valence electrons. How many valence electrons have we accounted for with all the bonds here? 2, 4, 6, 8, 10. So I have 4 left over. Where did they go? On the oxygen, because oxygen is the only one that doesn't have its 8 electrons yet, or its full outer shell yet. They just dump them there. Okay? And I want you to try CN. Do you know what CN minus is? That's cyanide. All right? That's the one that's not good for you. So CN minus. What? I can't hear you.
You should take a little class field trip to the supply closet and drink cyanide.
I can tell you how it works after. If everybody gets a structure, I'll tell you how it works.
Is this the structure?
Have you accounted for all the valence electrons? I can't see. I can't see. Yeah.
What?
Are we ready? Does it look like that? As long as you have a triple bond between the carbon and the nitrogen, and 2 lone pairs of electrons on each one, that is correct. Obviously, carbon wants to form 4 bonds, but it can't. So it forms 3, and it throws a couple of lone pair of electrons to stabilize it. Okay? All right. We're going to do some practice. Are we okay? Do you want to know how cyanide works?
We do a demonstration.
We're not going to do it.